Okay guys, for this one I'm going to show you a different way to find the equation of your trend line. So still you want to draw your trend line. Let's try to have the same trend line this time. So go through the origin, go through the 5, 5 point, and go just below this point. And that way we have the same line and we can have the same numbers on this one. Okay, so step one is to draw a trend line. Okay, your point slope equation, which is what we're using, looks like this. And I will explain all the different parts as we go through. Okay, so step two is to calculate your slope. All right, and so we're going to use this 5, 5, and then it's really hard when there's not lines on here. Let's say, you know, we may be lucky and that may go right there at 10, 10. So we may actually get rather lucky here with a 5, 5 and a 10, 10. Okay, so we're going to find our slope. So we're going to say y2 minus y1 over x2 minus x1. 10 minus 5 is 5. 5 over 5 is 1. So my slope is 1. Okay, and then step 3 is going to be choose one ordered pair. And your slope to substitute. And I'm just going to leave it like that because hopefully by now you understand we're substituting into our equation. Y minus y1 equals m times x minus x1. Okay, so I don't know y, I want to leave that as a variable. Let's just use this one. Well, actually, 10s are nice, so let's just do 10s. So we're going to say y minus y1, which is 10, equals m times x minus x1, which is 10. Now, if you remember your distributive property here, that means we have to do 1 times x and 1 times negative 10. So we're going to have y minus 10 equals 1x minus 10, or x minus 10. Okay, now this one's just kind of weird because of the way it's working out. But that's step 4 is going to be to simplify your equation. Which is what I just did here. Okay, and then we're going to solve for y. Okay, so by adding 10 to both sides, what I end up with is y equals x. And that means that my line goes through the origin and has a slope of 1. It goes up and over, up and over, and up and over, and it splits that first quadrant perfectly. Okay? So now that I have my y equals x, any point that I was given for x, let's say, what is y when x is 15? Well, when x is 15, y is also 15. This will not always be the case. This will only be the case when you have a line that goes through the origin and a slope of 1. In this case, we got very lucky that way. You can use this equation to make your previous steps that we did on the other foldable a little bit simplified. So instead of having to go through all of this, find the slope, plug it in, find the b, plug it in, find the y, you can just do it like this in a simplified form, kind of streamlined, and get all the way down to your equation. So it's really up to you. So this is left side, this is right side. Okay? And I'm just going to do one video for the next foldable too because this one's pretty short. So we are going to do we're going to do this one first. Okay, and again, we're not messing with this top part. It says, what does it mean for quantitative variables to have a relationship? In order for quantitative variables to have a relationship, they have to affect each other in some way. So as one changes, it has to make an effect on the other one. So that's what we're going to determine, is if there is a relationship here. If there's not a relationship, if your quantitative variables don't have a relationship, then there's no reason to do an equation. There's no reason to make predictions, okay? So we're going to go through and graph this data really quickly. Again, we're doing jelly and peanut butter, so we're not graphing the years. So 2,000 and 4,000, 2,000 for, now pay attention, 2,000 peanut butter is 4,000 jelly. And then we've got 4,000 peanut butter is 6,000 jelly. And 3,000 peanut butter is 8,000 jellies. 5,000 peanut butter, they sold 5,000 jelly. And 7,000 peanut butter, they sold 10,000 jelly. So make sure you always pay attention to your labels because this one threw us off a little bit. Even though we're starting down here and we're moving up, it says, is there a relationship between the sale of peanut butter and the sale of jelly? One could argue that this had a positive trend, that the more jelly that was sold, the more peanut butter that was sold. But if we take out that one outlier, we could also argue a negative trend here, or a positive trend here, or maybe saying no association because of the way that it's laid out. So it's also based on the years. So in 2010, they sold 2,000 jars of peanut butter and 4,000 jars of jelly. But then in 2011, it was 4,000 jars of peanut butter and 6,000 jars of jelly, 3,000 and 8,000, 5,000 and 5,000, 7,000 and 10,000. So the question is there any relationship between the sale of peanut butter and the sale of jelly between 2010 and 2014? Yes, peanut butter and jelly go together. But do people specifically buy jelly only because they bought peanut butter, or buy peanut butter only because they bought jelly? There's a lot of other reasons to buy peanut butter and jelly. So truly, there isn't an association. We can't predict how much peanut butter would be bought in 2020 if we knew how many jars of jelly were going to be bought, because it's kind of all over the map. And so there really is no association in this data. And so go ahead and answer your question up here and answer your question down here, and I will check those on Monday. And then again, I'm just going to keep rolling on the same video. We're going to do this one on the right hand side, and this is your last one. Okay, ignoring this. What is a line of best fit? We've been calling that a trend line. So what is a line of best fit? It is a line that best represents the trend of the data. It splits all your data points fairly evenly, however you want to do that in a complete sentence. Ryan owns a donut shop. The inventory data of his shop is given below. Make a scatter plot of the table. So again, I don't prefer it when there are no lines, but it's fine. So chocolate frosting, vanilla frosting, chocolate is 2, vanilla is 4. When chocolate is 4, vanilla is 4. When chocolate is 8, vanilla is 10. When chocolate is 14, vanilla is 12. When chocolate is 20, vanilla is 14, which is here. And when chocolate is 24, vanilla is 16, which is here. Okay? So it asks you what the slope is. Well, in order to find the slope, we have to have our trend line graphed. We have 1, 2, 3, 4, 5, 6 points, so we kind of want to split them. If I do my graph like this, then I've got 2 above and 2 below, fairly split evenly. So I'm going to go with that. And again, our trend lines may not be exactly the same. Let me plug in my iPad real quick before it dies. Okay. All right, so our trend lines may not be exact. That's okay. I'm going to scoot down this arm too. Hold on. Okay. All right. So in order to find the slope, I do still need 2 points. I can use this point right here. I'm going to say that's 0, 4. And I'm going to use this point right here, which ended up being my 2014. Okay, y2 minus y1 over x2 minus x1 is going to give me 10 over 20, or 1/2. So I have a slope of 1/2. And if you remember, we can now take this slope and one of these points, and on the notebook paper, we're going to go ahead and solve it out for an equation, okay? So let's take 0, 4 and 1/2 for my slope. So my slope is 1/2. My point, and if you didn't have a 0, 4 point, just choose one of your points. Remember, we're going to use y equals mx plus b. And if you need to organize this by saying, what is m, what is x, what is y, so that you can solve those out, then do it. M is 1/2, x is 0, y is 4. So 4 equals 1/2 times 0 plus b, or 4 equals b. So my slope is 4. So my equation would be y equals 1/2 x plus 4. Okay? So that is how we can use our trend lines to create our equations, and then we can use our equations to make our predictions. So if I wanted to use this equation to predict when x is 15, what is y? Remember, I would just plug that in. So I would say y equals half of 15 plus 4, or y equals 7.5 plus 4, or y would equal 11.5. So this would be 11.5. Where x was 15, y would be 11.5, which is roughly about here, but again, we're just predicting, so it is a fairly good prediction for this line. Okay, and that is it for all your different notebook pages. Be sure to turn in your warm-up, and be sure to put your quiz answers in the Google form. See you guys Monday.